Hello. Today we are going to be working on finding the area of regular polygons. We have a couple warm-up questions first just to get us in the groove, and then we'll dive on into some regular polygons. So for each of these, number one, we want to solve for the variable. This is a 30, 60, 90 triangle, so our labels for our 30, 60, 90 triangles are n, 2n, and n root 3, where n is across from the 30, 2n is our hypotenuse, and n root 3 is across from the 60. Since 24 is given to us, and that is our n root 3 side, we can solve for n and work backwards then to solve for what x is. So after we divide by root 3, we are then going to rationalize our denominator and get 24 root 3 over 3 to be our n side, which simplifies then to 8 root 3, which then plugging it in gives us an x value of 16 root 3. For number 2, to solve for y, I notice a right triangle. We're going to use SOHCAHTOA. So 72 degrees, we have the opposite and the adjacent. And so what we're going to do is we're going to set up the opposite and adjacent with tangent. So tangent of 72 equals 10 over y. We're going to solve for y by doing 10 divided by tangent of 72. That would be our exact answer, and our approximate answer is about 3.25 for our y value. For number 3, we want to solve for the legs of an isosceles right triangle. We're going to draw that. If the hypotenuse is 6, this is a 45, 45, 90 triangle, so we get n, n, and n root 2. Similar to number 1, we can solve for n, and we would get 3 root 2, which then would be the legs. So now what we're going to do is we're going to look at some figures here. 4 and 5 are both regular polygons because all of the angles are congruent and all of the sides would be congruent, especially for number 4 because all of the angles then would be 60 degrees. So for number 4, to find the area of this triangle, I can either do base times height divided by 2, or I could do s squared root 3 over 4 since it's equilateral. It all depends on what I'm given in the problem. So for this one here, I notice that my height here is 8 and my altitude is 8. When I draw that in my triangle, I actually create a 30, 60, 90 triangle. And by labeling all the sides with n, 2n, and n root 3, I can figure out the distance here across from the 30 is going to end up being 8 root 3 over 3. I also can label that on the other side here, which then would give me an entire distance or a side length here to be 16 root 3 over 3. So now I can use either formula. I can do base times height divided by 2. That would be 16 root 3 over 3 times my height, which is 8 divided by 2. Or I could have done my s squared root 3, which is 16 root 3 over 3 squared times root 3 over 4. And either one of these, when I simplify them, I'm going to end up with a final answer of 64 root 3 over 3 units squared for my area. For number 5, I notice that this is a regular hexagon. It has 6 sides. I'm told my perimeter is 84 feet, so if I take 84 and I divide it by 6, I can find each side length then to be 14. Now, if I don't have a formula for a hexagon, what I'm going to try to do is create triangles in this to help me figure out my total area. Because I know the area formula for a triangle, and I can then apply that, or multiply it by 6 in this case, because there would be 6 triangles in here. So if I were to draw in this triangle here, these two radii center to the vertices are congruent to each other, which makes this into an isosceles triangle. We have 6 different congruent triangles, so if we take and divide 360 by 6, we get each of these angles up here to be 60 degrees. And with the 120 remaining degrees, if we divide that by 2, each of these angles down here would be 60 degrees as well. For this hexagon, we happen to have 6 congruent equilateral triangles. So we can find the area of one of those triangles and then multiply it by 6 to get the total area of the figure. The area of one of those triangles is going to be s squared root 3 over 4 because it's an equilateral triangle. And then when I take and find that area, what I'm going to do is I'm going to multiply that by 6 because there are 6 of those congruent triangles inside this regular hexagon. And when I simplify that, I'm going to end up with a total area of 294 root 3 feet squared. So let's take another one. Let's find the area of an equilateral triangle given that the distance from the centroid to the vertex is 6. So you can see here we have our equilateral triangle. We want to show the distance from the centroid to the vertex is 6. So if I were to draw in my centroid here, the centroid is formed by the median. It goes from the vertex to the midpoint of the opposite side, meaning that these 2 points, or these 2 sides over here, are congruent. The distance from the centroid to the vertex is 6. And as we know, the centroid is 2/3 of the way from the vertex to the midpoint of the opposite side, meaning that this distance here from the centroid to the midpoint has to be 3. If I were to draw in the distance from the other 2 vertices to the centroid, because this triangle is equilateral, all of these different radii here from the centroid to the vertices are all going to be 6. And so based off of this, what we can do is we can find the different side lengths using this information and then use it to find the area of the triangle. Since this is equilateral, this median also is an altitude, making this angle a right angle. I notice that this is an equilateral triangle, meaning all of the angles are 60 degrees. So if I chopped it in half with this radius here, each of these angles would be 30, and therefore this angle up here would be 60 degrees. So now I have a 30, 60, 90 triangle, which means that this distance down here across from the 60 degrees is going to end up being 3 root 3, which makes my entire side here 6 root 3. And so that would be the side of my equilateral triangle. So you again have lots of options on how to find your area. I'm going to do base times height divided by 2 for this one, just to show a different way. My base here is 6 root 3. The height here would be 9 if I were to take and add the 6 and the 3 together. And then when I divide that by 2, that would give me the area of this triangle. So the area is going to be 27 root 3 units squared. Okay, so for our next one, we want to find the area of a regular octagon that has a radius of 10. Once again, we don't really have a formula yet. We'll give you one in a little bit, but if we don't have a formula, we need to work with what we know. So if we have this regular octagon, the radius is 10, means that from the center of the octagon to each vertice, that distance is going to be 10. And so what I can do is I can draw in a triangle. Again, I'm going to go to what I know. I know the area formula for a triangle. If I'm able to find the area of this triangle, then what I could do is I can say, hey, since this is a regular shape, if I draw in all of my different triangles, they should be congruent to the one that I have labeled. So if I find the area of one triangle and I multiply that by 8, then I would have the area of the shape. So I need to find the area of that one triangle. I have a couple formulas I can do. Base times height divided by 2. It is not an equilateral triangle, so I can't use that formula. But I also can use 1/2 AB sine of C. I'm able to use that as my area of the triangle. So I have A and B. They are both going to be 10 in this case. So I'm going to do 1/2 of 10 times 10 times the sine of the angle in between those two sides. So right now my goal is to figure out what this angle is. And so looking at this all the way around is 360 degrees. I have 8 different congruent triangles. So what I can do here is I can do 360 divided by 8 to figure out what that central angle there would be. And so by doing that, I find out that that angle is going to end up being 45 degrees. And if I do 1/2 AB sine of C, I would get the area of that one triangle. I take and multiply that by 8 to get overall my total area. So if I were to then take this and simplify it, it would be my exact answer, and I can type it in on my calculator to get my total answer of 282.84 units squared for my area of my octagon. So let's try another one of those, again, not relying on a formula, but just on what we know to calculate the area of this regular pentagon. So the perimeter here is 40. If I were to take 40 and divide it by the number of sides, I would get each side length to be 8. Again, my goal is to find the area of the pentagon, so I'm going to split this up into triangles. Since it's regular, all of my triangles then are going to end up being congruent. So I have 5 congruent triangles. So if I take the area of one triangle and multiply it by 5, it would give me the area of the pentagon. So I'm going to use something similar. I'm going to find that measure of the central angle for each of these since they are congruent. If I do 360 divided by 5, that's going to get me my total measure of each interior angle here, or central angle, to be 72 degrees. And if I were to draw in now my altitude in one of my triangles, that means each of the angles up here would be 36 degrees. Drawing in that altitude also is going to bisect the side because these triangles are isosceles. And so now I have an angle, a side, and I can actually find my height here for this triangle. So using SOHCAHTOA, the tangent of 36 equals 4 over whatever that height of that triangle is. So I can solve for that height, be 4 over the tangent of 36, which happens to be about 5.51. So if I actually store that in my calculator for my height, what I can do is I can do 1/2 the base of my triangle times the height of my triangle. Again, that's a stored value. That's the area of one triangle, and if I take and I multiply that by 5, that's going to give me the area of the pentagon. The overall area after typing that all in my calculator is going to be 110.11 units squared. So overall, based off of all of these examples, we can come up with a formula to find the area of a regular polygon. What we can do is for any regular polygon, we can take the area of one of the triangles and we can multiply that by the number of sides in the triangle or in the polygon. That's one of our formulas we can use. Again, find the area of one triangle, and all of the triangles in the regular polygon would be congruent, so then therefore multiply by the number of sides. The other method is to find the area is going to be 1/2 of the perimeter of the polygon times the apothem. This is known as 1/2 PA. Now, I might have said a new word for you, the apothem. So looking at this, we have a polygon with n number of sides. The radius here is going to be the distance from the center to the vertices. The apothem is the distance from the center to the side. And since it's the distance, it is this right angle is implied here. So your apothem is going to be the height of the triangle pretty much. So 1/2 the perimeter times the apothem would give you the area of the regular polygon.